Hey, financial modeling guys. So what I'm going to do today, this is a little bit more savvy video for the savvy math. It's not part of the curriculum. I just want to show you some proofs because some of you guys wanted to know how the proofs are done. So that's why I wanted to show you. Okay. So what I'm going to do, I'm going to show you the covariance for beta, right? So before I do that, let me just state a very simple, nice rule that you can actually use not only here, but anywhere you go. So let's say that you have y, a random variable, and assume, right, that that you know that covariance of y equals basically c. Okay? Now, if you take y, right, and you transform it h times y, where h is a constant matrix, okay, and y, let's say, is a normal, but it shouldn't be a normal, it can be anything, okay? And now, right, you're asking yourself, gee, what will be the covariance of hy? Right? So y is a constant, is a variable, right? So h times y is basically a bunch of random variables. What you want to do, you want to know, if you know the covariance of y, can you find the covariance of hy? Okay? And the covariance of hy is actually going to be hc, h transpose, right? And you know, it's actually pretty straightforward to show. For example, you can actually take, the first one, which is h11 y1 plus h1, plus h12, let's say, or y2 plus yada, 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 hy n yn, right? And, you can say that it's going to be, let's say, with, I don't know what, with h31 y1 plus h32 y2 plus yada, 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 h3n, yn. And you can actually multiply, right? Use the covariance rules. So basically, you can say that this is basically going to be the covariance h1i, h3i, whatever, the covariance of yi, yj, or something like that, right? And then what you're getting here, you're getting exactly this guy. Okay? Now, there is a neat trick that you can think about in the following way. You can actually think about C, right, your covariance matrix for y, as being y to y times y transpose. Now, this is not going to be all correct every time, but it's going to be correct if the expected value of y is going to be 0. And indeed, just remember what is the expected value of x1, x2, right? E of x1, x2, this is your covariance, right? And now, if this is 0, then this is going to be x1, x2. So if you think about cy like that, then it's actually very simple to think about this, which is going to be the covariance of hy, right? And now when you open it, it's going to be hy times y transpose times h transpose. And this is, if you think about, right, that AB transpose equals to A transpose, B transpose times A transpose. Okay? So when you have a multiplication of matrices and you want to transpose, you just swap the BA and you put the transpose. Okay? Now, what happens with beta? So recall that beta equals to x transpose x inverse times x transpose y. And now what you want, right? And now what you are looking for is beta conditional on x, right? We talked about this in class, that all the confidence intervals, all of it, right, is under what we call weak exogenetic assumption, where x, right, is actually known. So all your statistical distributions on beta, right, depends on x. Okay? So then remember that in this case, y equals to beta x plus epsilon, right, plus alpha. And then the covariance of y is going to equal to covariance of epsilon. Okay? So what you can do here, when you're talking about, when you're talking about beta transform x, right, you can actually replace this y with your epsilon. So you are going to get that now what you're looking for, you want the covariance of this vector times epsilon. Now, how do you do that? Well, you can actually use this rule, right? And you can say that this equals to what? To x transpose x inverse, right, times x transpose times epsilon, right, times, and now you want to transpose. So you're going to get the same thing, x transpose x inverse times, x transpose times epsilon, but all this in transpose, right? So if you do that, what will you get? Well, you get something very interesting. You get x transpose x to the inverse times x transpose, right, times x, times, and now epsilon times epsilon transpose, and now times this part, right, x transpose x inverse in transpose. Now, observe that this guy, right, is actually sigma square, right? So it's a diagonal matrix. So if you take a matrix H and you multiply by a diagonal, it's just like taking the matrix, multiplying it by the number. So this guy, you can actually say that this is sigma square times x transpose x inverse times x transpose x. And now you times this guy, right? So it's going to be x transpose x inverse to transpose. Okay? Now, you see what happens here, that this guy and this guy goes away. Now, this is really you have to be careful here, because x transpose x is defined only for this guy. It is not defined, you cannot say, right, you can actually say that you could think, oh, AB inverse equals to B inverse times A inverse, right? However, this is going to be wrong in this case. Why it is going to be wrong? Because remember, right, that x transpose x inverse is not defined, right? What is x? X is a vector. Vectors do not have transposes, so you have to look only on the entire thing. However, you see that it's here, so you can cancel. So what you are going to get here, right, is going to be sigma square times, and now you're going to get x transpose x, right, inverse transpose. Okay? So this guy is exactly the covariance of x, right? Covariance, because, I assume that, right, x transpose x, we more or less can think about this as a covariance. I'm assuming it's a covariance, but, I mean, because the x is well defined, right, we don't have that it is a covariance. I mean, it's just we're morally thinking that it's a covariance, right? But that's exactly right, the formula that I gave you in class. Okay? So that's your covariance of beta. And once again, right, it's actually very important to understand what's going on here. This expression is only conditional on x, okay? So you're not assuming that x is a random variable. It's very, very important. We did not assume here that x is a variable, right? We assume that we know x. And all the randomness for y is coming from epsilon. Only then we can play this game, okay? So hopefully this is a short video, but I hope that it's kind of give you some hint of how to prove such formulas, okay? So the main thing, right, is to actually think about cy as y times y transpose. And I guarantee you, if you think about in this case, right, in this way, then all these formulas are actually coming from the fact that hy times hy transpose, and when you transpose it, you get all this kind of stuff, okay? So that's it for now, and hopefully you enjoy this video, and I'll talk to you in class, and we will start to talk about, all these AR1 processes, all that stuff, and then I'll record videos about it. Don't worry, all right? So I'll see you around. Bye.